Welcome back to ISOmath. In this video we're going to talk about some areas of simple regions. For example, first we're going to talk about the area of a rectangle. Let's draw a rectangle. Okay, we have a rectangle here. And what I want to look at is really what area is. Probably most of you probably already know the formula for area, but I would say that probably some of you don't really understand what it really means. So let me break this thing into little 1 by 1 squares. And we see here that we have this is a 3 by 1, 2, 3, 4 rectangle. And most of you probably know that, let's say this is 4 feet and that's 3 feet, and that the area is going to equal to 3 feet times 4 feet, which equals 12 square feet. Alright, feet times feet gives me square feet. 4 times 3 gives me 12. And most of you probably already know that. But what I want to make sure we understand is, what does it mean to say something has an area of 12 square feet? Well, what that means is that we have we can fit 12 1 by 1 squares into the area. Whether it's a rectangle or not, to say that a circle was 12 square feet, which I don't think you're going to find a circle with 12 square feet, but you could get approximately close, would mean that you could fit 12 1 by 1 squares in it. So if you see there, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So an area of 12 square feet means we could fit 12 1 by 1 squares into that area. And so the area of any rectangle is going to, area of a rectangle is going to equal to the base times the height here, or length times width, however you want to look at it. Base times the height. Okay, so the area of a so know that a square, we'll go down 1, 2. So yeah, here's a square. Here's and a square is a rectangle, by the way. So this is 2 by 2, and so our area is going to be 4. And if you look at it, we can divide it into 4 1 by 1 squares. So again, if we're in feet here, or whatever your favorite measurement is, the area of this triangle, which is, the area of this square, which is a rectangle, is going to be 2 times 2, 2 feet times 2 feet, which is going to equal 4 square feet. Okay? Now let's jump to a parallelogram. First, let's draw a parallelogram. There, and let me go there. So parallelogram is going to be a figure that looks like this, where this side is parallel to this side, and this side is parallel to that side. Note that a rectangle or a square are both parallelograms as well. So we want to see how to get the area for these. And this is hand wavy, but let's look at this. If we look here, and let's look at, so this square here that has a length of, in red, so we have what, 1, 2, 3, 4, 5, has a width of 5 and a height of 1, 2. Okay, if you the area of the square in red, so, or the rectangle equals 5 times 2, which equals 10, and it'd be square feet, square meters, square inches, whatever your increments of measurement are. But if you notice here, it looks like that when we took this, so you imagine taking this square and using that square to just form it and to make this parallelogram. And so we lost that much area. But if we look over here, we gained the same amount of area. So the area of the parallelogram is still going to be, so the area of the parallelogram is still going to be base times height, where you get the base from, pick any one of your top or bottom there, so they're the same length, and so that's going to be my base, and the height is going to be given by the perpendicular height here to the other side. So the area of a parallelogram is the same as the area of a rectangle, but you don't measure you don't measure the length of that side to get the area. You get the actual perpendicular height here. So base times height, and you see that it's derived directly from the area of a rectangle. Okay, how are we doing on time? Looking good. We've got one more that I want to look at. The area of a triangle. Let's draw a triangle. There's going to be the triangle. And so now, to see how we get the, I think most of you know it's 1/2 base times height, but let's see how we get it. See that this side over here, I'm going to copy that side here, okay? And now this side here, I'm going to copy here. And so we have the same, we just copied the triangle, and we see that we formed a parallelogram. So the area of the triangle here is going to be half that of the area formed by the entire parallelogram. So the area of a triangle is going to equal to 1/2 the area of the parallelogram of that parallelogram we formed. But we know just from a minute or two ago that the area of the parallelogram is going to be, if I call this my base, and then the perpendicular height to the top of it, call that h, it's 1/2 base times height. And so that's where that formula comes from. And again, I know that most of you are probably familiar with these formulas, but I think it's important to really think about where they come from. So the area of a rectangle is simply going to be the number of 1x1 squares that will fit in there. Alright? And the area of a parallelogram is the same. It's still going to be the number of 1x1 squares that will fit in it. But we see we derived the formula straight from the area of a rectangle. And then we derived the formula of a triangle simply using the formula for the area of a parallelogram. So it's all still going to be, when you find the area, it's still going to represent the number of 1x1 squares that will fit inside of the figure. Okay? Thank you.